Welcome to NPTEL Week 9. Today's session, we will be covering different kinds of sorting and searching algorithms in C, and on top of that, we will also be covering compiler preprocessor syntax in C. And first, we will go through the assignments, which will include MCQs, and then we will go on to discuss some of the programming assignments from last year. And as usual, I am hoping that with these will be comprehensive enough for you. With that, you can equate with the knowledge of these, you will be able to answer the questions from this year. And you'll be well prepared and confident enough to use different sorting and searching algorithms in C and also use various preprocessor macros. So let's get started. I'll wait for a few minutes for people to join in and then we can get started. In the meantime, let me just share the screen and open up the MCQ page. Okay. Okay, so let's get started with this. And here is the first question, which asks what's the worst case complexity of selection sort. So the way this selection sort works, so let's just have a short look at how this thing works. So here it works by just swapping elements. So let's this is like a famous, quite popular portal, which is quite comprehensive in terms of different algorithms. You might have also gone through all of these in the lecture videos. So I'll just quickly want to reiterate on this so that everything is clear. And then we can think about what's the, try to answer this MCQ, right? Okay. So let's consider this array. So you see we have this array 64, 25, 12, 22, and 11. So now what happens is the first position in the sorted array. So we want to kind of have sorting like a selection sort. So we are sorting this array, and at the end, what we want is this array to be sorted in ascending order. So the smallest number should be at the left and the largest number should be at the right. Okay, so we start with the initial array, which is obviously unsorted, and now we are using selection sort. So the first position in the sorted array, the whole array is traversed from index 0 to 4. So yeah, as you know that in C, all the arrays start getting counted from 0. So the first element has an index 0. So 0, 1, 2, 3, 4. And the last element has the index 4, right? So for the first, that's why it's written that the first position in the sorted array, the whole array is traversed from index 0 to 4 sequentially. First position is 64, is sorted presently after traversing the whole array. It is clear that 11 is the lowest value, right? So you start with the first position and you check which is the lowest element in the array, and after you have gone through the array, you have found out that the lowest element is, so after one iteration, which happens to be the best, happens to be the least value in the array, tends to appear in the first position. So now what you do is you swap the last and the first position because you have identified that this is the smallest element, right? So once you have done this, your first element is now properly placed. So you go to the next, and then you have one less element compared to the entire size of the array to sort. So now you start with this like the second element, or by in terms of C language, it's as an index of 1, and this the value is 25. And now you again keep on comparing and finding out the smallest element, and out of all the remaining 4 elements, you see that the element at index 3 is the smallest element, which is 12. So you now again swap these, and once you have swapped these, the next one is then obviously your 12 and 25 got swapped. So on the left, now 2 elements in the array are sorted and put in their correct position, and the 3 elements still needs to be sorted. So now here you are, and then again you do the same thing. Here you have 25 and 22, and you check out of this, obviously out of these 3, you find out the smallest one, which is this 22, and then you swap your 25 with it. And once you have swapped it, obviously this is sorted. Now you have to check the final 2 elements. So you check these two, 25 and 64, and you see that obviously the 64, which is to the right of 25, is larger. So there is no need for swapping, and you are at the end of it, right? So the idea here is that if you are at some position and you check if there are any elements to the right of it which is smaller than this, then you swap it, and you swap smaller than this, so you find out the smallest element and you swap that. And if you are already the smallest element, then you do not swap anything. The array is obviously already sorted, and then you move to the next one. So you see that the number of swapping operations. So the complexity is how many swapping operations that you need to do. And in the worst case scenario for this is that say your array is in descending order and you want to arrange it in ascending order. So you have to do all the swaps for this, and that will go as n square, because for every element you are searching n minus 1 elements and finding out the smallest and then doing the swapping, right? So it's roughly speaking, it's actually n times n minus 1, but when we speak of order, because n minus 1 and n are quite comparable for large values of n, so the order is actually n square for the worst case scenario. So the right answer in this case, so let's go to the assignment. Okay, let me do this. Right. So as you can see in here, the worst case scenario is the order of n square. So this is kind of the logic behind this. So at this point, if any of you have any questions, then please feel free to ask me. Otherwise, I'll just go on to the next one. Okay, so let's go on to the next one as what is the best case and worst case complexity of an ordered linear search. So uh, excuse me, just excuse me for 2 or 3 minutes. I'll be Hello, am I audible? Uh, Sorry for the interruption. I hope I'm audible. Sorry for the interruption. It's my computer has crashed, because of which I was not able to log in to my computer, but uh, I have now been able to come back. So please hold on for a while I again open up the MCQs and set up the screen, and then we'll again resume what we are discussing. Okay, I think I have been able to set this up. So let's try to let me try to share my screen, and then again we will okay. Sorry once again for all the interruption. As I was saying that my computer had crashed, because of which I had to again open up everything, and that caused the interruption. So yeah, please excuse me for that, and then we can let me share my screen, and then let's resume what we were discussing. Okay, so let's go back to where we were. So yeah, this was like, what's the best case and worst case complexity of an ordered linear search. So an ordered linear search would mean that you are searching through an ordered array, and you are just going through one at a time and just finding out whether you match it or not. So the best case would be in this specific case of uh, is that you say you are finding for one element, and that element is right in the beginning, right? So then it will require just one step. You are at the first step, and you are lucky enough that the element is right at the beginning. So the best case scenario is order one, while the worst case scenario is the element is right at the end, and you just keep on searching one after the other. And whenever you hit the end, you know that either you find the element if the element is there at the end of the array, or you do not find it at all, so then the element is not there. So that's the worst case scenario, which is of the order n, because you have to search through n elements, where n being the length of your array. So the right answer here is O1 and On. Okay. So now let's move on to question 3. And at this point, if you have any doubt, please feel free to ask it either by unmuting yourself, or you can also post it on the chat, so that I'll be able to listen to that. If any of you do not have any doubt, then we can move on to the next one, which is question 3, where it's that given an array ARR and the key 34, what are the mid values corresponding to this? So this is like a binary search which is going on. So let's open up the page for binary search. so that I can just reiterate you through what is going on, and then we can discuss this more. So again, I'll open up this famous website of quite popular one. This is Geek for Geeks, which often I use for going through all of these algorithms. So one of these is binary search, which I was talking about. So what this means is that you need to have an array for this binary search to work. You need to have an array which is already sorted, and I'm assuming that it's sorted in ascending order. So smallest number is at the leftmost, and the largest number is at the rightmost position in your array, right? So now you look at the index, and so the first index is 0, and the last index is the size of your array minus 1. So what you do is you find the mid value. So the mid value will be here, low plus high minus low by 2. So that's kind of the mid value, and you also do, I mean, this can sometimes give you a value which is not an integer. Then what you have to do is you have to kind of get ignore the decimal place and round it down, basically. So you have to round it down by ignoring the decimal place which comes, because array indices are always integers and decimal values do not count, right? So the way this works is that since your array is sorted and you have one value which you are searching for, you look at the highest index and the lowest index and then find out the mid index of there. And if you see that your array is the value which you are trying to find in the array, if this is larger than the mid value, then you choose the right part of the array. Otherwise, I mean, to the right of this mid value or the entire array, or you choose to the left of the mid value of the entire array if the mid value is kind of larger than what you are searching for, because this is a sorted array. So if your mid value is larger than what you are searching for, then you know that the number that you are searching for must be to the left of this mid value. So that's the array that you choose. Or when and when it is smaller than the number which you are searching for, then it's obviously has to be to the right, and then that's what you choose. And if it is equal, then congratulations, you have already found it, right, which is the index of the array in which you are searching for, right? And you do this. So what with this, what you are doing is a large array, you are slicing it into two pieces and discarding the piece where the search element doesn't is not there. You are not doing anything. You are sure that it's not there because it's sorted, and then you do the search in the other part, and then again you slice it. So you do this iteratively, slicing your array into smaller and smaller by roughly by half, and until you find the element which matches or the element is not there in the array itself, right? So that's kind of the idea here. And so let's go back to the question then. So what this asks is, what would be the mid values? So as you can see, this is an array of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements. So it's an array of 9 elements. So the first, so in terms of C language, since every index starts from 0, the first element, the index of the first element is 0, and the index of the last element is 8, right? So we now use the formula to find out the index of the mid element, and if you recall, the formula is low plus high minus low by 2. So we know low is 0 for us and high is 8. So we do something like 8 minus 0 by 2. So this gives us the mid value of 4. So for the first iteration, your mid value is 4. So this corresponds to, then let's see what is the value of the element in the index 4. So here, let's see 0, 1, 2, 3, 4. So the value is 85. Right? So the value is 85, and now we want to find out where the value 34 lies. So we know that this value of 85 is larger than 34. So we have to choose the part of the array to the left of this index. So everything to the left of 85. So the new array on which we will do the searching is basically everything to the left of 85. So then that would mean that the last index to search for is 3, because the index 4 we have found out to be larger than 34, right? So now so we now update the high value. The low value still remains 0, right? But the high value is now updated from 8 to, it now gets updated to 3, right? So now again we are doing the slicing. So what we'll do is we'll do something like again low plus high minus low by 2. So 0 plus 3 minus 0 by 2. So that gives you 1.5, right? But we already know that we will round it down and do not consider the decimal part. So what we will consider is 1. So 0 and 1. So the the array element with index 1 is 34. So this is the one. This is 34. So 85 and 34 is the right answer in this specific case. Okay. So now let's move on to the next one. When the binary search is best applied to an array. So these are the certain things. So you know that the binary search is only going to work. So what I was discussing before is binary search, and this is only going to work if your array is sorted. So binary is best applied to an array which is sorted. So this is the right answer is B. The array needs to be sorted. Now consider the array A, which is 54913. So this is the array, and apply insertion sort to the array, and consider the cost associated with each sort is 25 rupees. What is the total cost of the insertion sort for sorting the entire array, right? So the way insertion sort works, I'll again kind of walk you through that to refresh your memory, and then we will try to answer this question. So let's go in here. Okay. So what you do in case of insertion sort is that you start sorting your array in a way such that your array is always divided into a part which is sorted and a part which is not sorted. And then you move, and the part which is sorted becomes larger and larger with every iteration, while the part which is not sorted becomes smaller and smaller until your entire array is sorted. So 12, 11, so let's take this example of 12, 11, 13, 5, 6. So then what you, so we are assuming that we want to sort this array in ascending order. So again, the smallest value goes to the left and the largest value goes to the right. So we start with this, comparing the first two elements, and we see, so the idea here is that you insert the correct element after sorting to its correct position. So that's why its name is insertion sort. Okay. So here, after the first pass, you see you just compare. So initially you'll have something like a 12, 11, 13, 5, 6. So this is what is given. And then you see that, okay, I compare the first element with the second element, or the element with index 0 with element with index 1. And we see that 12 is obviously greater. So this needs to be swapped. So we swap it. And then you have something like 11, 12, 13, 5, 6, right? And now we will know that everything to the left of this is now kind of sorted already, right? And has been inserted to the correct position as far as the comparison which we have made, right? Now we are going to the next one where we are comparing 12 and 13, and we know that, okay, this looks okay because 12 is obviously smaller than 13. So we'll do nothing and then move on to the next a pair where we compare 13 and 5. So here, you know that the 13 and 5, in this case, that the left-hand side is larger, so 13 is larger than 5, so this requires a swapping. We swap it, and after this, we again check. So every time we check after swapping with the number which we have swapped to the leftmost one and see whether it's smaller or larger. So now, once we have swapped 13 and 5, I check the leftmost one and I see that, okay, so let me just go back and tell you here after sorting what we have done. So we have sorted 11 and 12 in here. We have swapped 11 and 12 in here, and now I consider 12 with 11, and I see that it's larger, so there is no step needed. In the second place, I again compare 12 and 13, and I see that it's 12 is smaller than 13, so again nothing is needed. And here now I compare 13 and 5, and I see that 13 is larger than 5, so this requires a swapping. I have swapped it. And now I compare again 5 with the leftmost value, and now I see 5 and 12. And out of 5 and 12, I see that this is 12 is larger. So again, this requires a swapping. I swap that. And then I again compare 5 with its value on the to the left of it, which is 11. So again, 11 is greater than 5. Then it requires another swapping. I swap this through. Okay. And once I've done this, the place where I've started this entire procedure of swapping was at 13. 12, and so now we're at positions of 3 and 4. So now this is sorted. So now I'm looking at the position of 4 and 5. So now you see you have 13 and 6. And obviously you see that 13 and 6 is requires a swapping, so you swap that, and then again you compare 6 with the leftmost value, and you see this is not right, requires a swapping, so you swap again, and you keep on swapping this unless this 11 and 6 as well, unless you come here, and here you see that 5 and 6. This doesn't require a swapping anymore because 5 is smaller than 6, and so this is the end of this swapping stage. And since this swapping, then this entire swapping thing started from comparing the second last with the last element. So we know that we are already at the end, so the entire array is sorted and things are inserted to their right position. So this is how this entire algorithm works. So let me now go back to the appendix question. At this point, I'll also check if there are any questions in chat. I don't see any. So, okay. So let's go here and see what's happening in here. And the cost associated with sort is 25. Okay. So the idea is we need to find out how many sorts or swaps that are required. So let's start with 54913. So let me share where I'll just scribble out things. Anyways, I think I'll use a notepad for this, just to demonstrate what is happening. Okay, so let's open this up and let's have this in here, and this is fine, I guess. And let me have this in here. Okay, so where is this? Yes, 54913. So you have 5, 4, 9, 1, and 3, right? So here, obviously, you start with comparing the zeroth element at index 0 with the element at index 1, and you see that this is not this is requires a swapping. So obviously, the swap will happen. So you have 4, 5, 9, 1, 3, and now you compare it to the element on the left, and you see that this is larger, so that there is no swapping. That's no more swapping that's needed, and then you come back, and then you come in here, and then you compare the next one. So this is 4 is obviously right, and then you see that whether you need a swapping in here or not. 5 and 9. So obviously you do not need a swapping, so it remains the same. Right, and then you come here. So one swap had occurred in here, so I'll mark this with S. So by S, I mean that there is a swapping that has happened. Here, there was no swap that has happened because we compared, and you see that 5, so this 9 is greater than 5, so there was no swapping. And then we compare 3 and element at index 3 with element at index 4. Sorry, element at index 2 with element at index 3. 0, 1, 2, 3, yeah. So you have 4, you have 5, and now this requires a swapping because on the left you have a larger value. So you have 1, 9, and 3. And here we have made a swapping. So I will put an S in here. And again, you see that this value 1, and now I compare after swapping, whatever I have swapped to the value which is at the left. So I obviously see that the value to the right is smaller, than it requires another swapping. So I'll have a 4, 1, 5, 9, and 3, and I will mark another S in here. And then again, I am comparing it with 4, and I see, okay, this has been requires a sorting once again, so like a swapping once again. Sorry for mispronouncing this. So you have a 1, 4, 5, 9, 3, right? And I'll again mark swap with this, right? And now at the end, you see that we'll compare the last two elements now. So you have a, and obviously you see that there is a comparison which shows that the the left element is larger, so the swapping is needed. So 1, 4, 5, 3, 9, and I'll mark a swap. And then again, I do the comparison with the thing on the left, and I see that, okay, this requires a swapping. So I have a 1, 4, 3, 5, 9 and a S. And then again I do 1. Uh, so this again requires a swapping because again this is 3 is smaller. So you have 1, 3, 4, 5, 9 and a S, right? And then again I compare it with a thing on the left in here. So you see that there is no swapping that's needed because this and things remain the same, right? So we have identified how many swaps we have done in here, and now but these can be bunched together, right? Because this is the first one, and then all these swaps, like uh, you start with this and you're bunching it all together. So this entire thing where this sinks down, you see the value is sinking down in here. So you see here there was the first swap that's done, and let's see. So the up till this where you see that the value of 3 has swapped and got to its correct position. So in initially like we swapped this thing which was this 4 and 5. So this was swapped for the first time, and then we didn't swap anything, and then we swapped this 1 and uh, 1 and 5. I think this is the one where which we have swapped. So sorry, 1 and 9. So this is where we have done what most swapping, and all these 3 swapping has been, after all these 3 swapping, you see that the value of 4 like 1 has got to its correct position, and then next 3 swapping corresponds to the next one where things have been moved to the next position. So in total, we the sorting we have done like uh, 6 and 7 swapping, but out of this, the first swapping corresponded to the first 2 elements, and then the next 3 swapping corresponds to the next pair, and the other 3 swapping corresponded to the next pair. So we had, in principle, swapped 3 pairs, or sorted 3 pairs. In a sense, we have made 7 swappings but sorted 3 pairs, and it says that the insertion or sorting 3 pairs at the end, which costs you 25 rupees. So you have done this 3 times. So the right answer is 75 in here, because there are 3 kind of swaps that were 3 kinds of sorting, 3 steps of sorting that was needed, and that included 7 swaps. At this point, if there are any questions, please feel free to ask. Otherwise, I can just move on to the next one. Okay, so the next question is, which code snippet performs an unordered linear search iteratively? So you just, this is very simple. A linear search is just moving through the array, and you see starting from the 0th element to the last element, which is n minus 1, if the size of the array is n, and you just try to see if you find a match. So if you look at the first thing where you have an index, and you start from 0 and obviously go till less than size. So this is size minus 1 and I plus plus. And if array I equals to data, then index equals to I. And you break it because you have found the match. You break it and you just return the index. So I think the first the first option itself is the right option, because what this does is it goes through all the elements in the array, tries to find the match, and as soon as there is a match, it assigns index to I and breaks it and returns the index. The next one just breaks it, but the index is not assigned. So this doesn't work for the next case. And for this case, continue happens. So then this would mean is that you keep on moving through the array, which was not needed. So this is unnecessary because you have already found out the match and you have assigned index. So you do not continue, you just have to break out of it, right? So the right answer here is obviously option A, where you just break it, you assign the index I, and you just break out of it. This will work in principle, the option C, but it will take a lot of time because you have already found out the match, right? And if you have duplicate elements, then it will give you the last match in that case. But you don't need to go into all that confusion, and also you do not have to try matching other elements once you have already found the match. So you have to break it and not continue the loop. Okay, so coming to the next question. So I think there are no questions because no one has asked any till now. Yeah, I don't see any questions on chat. But yeah, please feel free to unmute and ask questions if you see if you have any doubt anywhere and want me to repeat anything. I'm happy to do that. Okay. So let's move to the next question, which is about preprocessor macros. As you can see, there is hash include of stdio.h, and there is func1 and func2. So these are like two preprocessor macros. One is func1, the other is func2. And the first, so what this preprocessor macro does is it replaces the part where you will have func a comma b with whatever value you define with a hash define. So this is done by the compiler itself when you are compiling the code, and not done at runtime. So that's why these are called preprocessor macros. Okay, so you see we are passing func1 with a and b values. So the a is 3 and b is 5. And then what this will do is that compare 3 with 5, and if 3 is greater than 5, which is not, then the value will be assigned as a. So the entire thing func a comma b will be evaluated as a, which is 3, because we know that 3 is not greater than 5. So this ternary operator is going to give you 3. So 3 plus 3 is what will be done in here. So 3 plus 3 is 6. Now 6 is greater than b because you see that the b value of b has been assigned as 5. So 6 is greater than b. So this is true. So you'll go inside the if statement and evaluate func2. So what func2 does is nothing but it takes a and b, and you see this is the familiar swapping algorithm which you have obviously encountered over many weeks. We have done this. We have done different types of swapping. So this is like a swapping algorithm, and it swaps the values of a and b. So we have passed a as 3 and b as 5 in here, and since this is passed not as a function but as a preprocessor macro, this entire part of the code is just replaced in here. And because of that, there is no concept of like pass by value or pass by reference which is going on. It's just long, there's like broad chunks of code which are replaced by the compiler in the places where it encounters func2ab. So you kind of swap the arrays. So a becomes 5 and b becomes 3, and that's that is getting printed. So an answer for this is option D, 5, 3. Okay, so now let's consider an array of elements 5, 4, 3, 2, 1. What are the steps of insertions while doing the insertion sort algorithm? So we'll again do the same thing, just like this. Find out what's happening. 5, 4, 3, 2, 1. Right, and we will do the insertion sort. So we will compare the first two elements first. So obviously you see that the 4 is less than 5, so we'll do the swapping. So 4, so we'll do here 4, 5, 3, 2, 1. Right, so this is kind of the first comparison. So I'll just also give an enter. Previously we had some confusion regarding how many swapping, not swapping, but insertion steps that were there, or sorting steps that were there. So I'll just do that, give some enters as well in here just to distinguish. And now I compare 5 with 4, and I see that this is in proper place. So I move on. The next one where I compare 5 and 3, and here obviously this requires a swapping. So I'll do a 3, 5. So I'll just swap this 3 and 5. So I have 3, 5, 2, 1, 5. And I mentioned that I have done a swapping in here. And then again, I compare then. So I have just swapped this 3 and 5, and I again compare 3 with the left hand, whatever on the immediate left hand side of it, which is 4, which is larger. So this requires another swapping. So I'll do a 3, 4, 5, 2, 1. Sorry, why I think I have This was just, I have put this by mistake. I'm sorry about this. Okay, so this is the swapping. And so now 3 is at the leftmost position and there's nothing to compare it with. So I move on to compare the next two elements, which is 5 and 2 in here. So I'll just give an enter because now I'm doing to the next swapping sorting step. So 5 and 2, so obviously this requires a swapping. So I have a 2, 5, 1, S, and then again I go in and I see that 2 and 4, which is obviously 4 is larger, so another swapping is needed. So I have a 3, 2, 4, 5, 1, S, and then one more swapping needed. So I have a 2, 3, 5, sorry, 4, 5, 1, and S, and that's it. So I have reached to the end of it and there is nothing more to compare to with the left of it. So then now comes the last sorting step where I check the last two elements, and obviously this requires one more again a sorting. So I have a 2, 3, 4, 1, 5 and a S. So because I have done a swapping in here and then again I compare it to the left. So this sinks down. So I have a 2, 3, 1, 4, 5, and then I have a 2, 1, 3, 4, 5. I think by this time you must be pretty confident about what are the steps that's being taken. So you have 1, 2, 3, 4, 5. Now the last now one has reached to the leftmost position and we have also reached the end of the array. So this is the end of it. So now you have been asked to find out what are the steps. So obviously we have started with 5, 4, 3, 2, 1, which we do not include. And after the first sorting step, you have a 4, 5, 3, 2, 1. After the end of the next is 3, 4, 5, 2, 1. Next, and then the next sorting step is 2, 3, 4, 5, 1. And finally, the last end of the last swapping step gives you 1, 2, 3, 4, 5. So you see, this is something which is matching with this element where you have 4, 5, 3, 2, 1, 3, 4, 5, 2, 1, 2, 3, 4, 5, 1, and 1, 2, 3, 4, 5. So these are the steps that the end of every sorts. So here, you see the same thing has been done. So this is the first one, which is the right answer in here. Okay, so now let's come to question number 9. And before that, I don't see any question in the chat. So I'll just straight off ahead, move on to question number 9, where it's been asked to find out the output of the following C code, where A is 1. Where now again, this is a preprocessor macro that has been used. So hash if A equals to 1, hash define B equals to 0, else hash define B equals to 1. So you see that nothing has been defined about A. So the first part is not true. So hash else is the one which will be used, and B, the value of B will be fixed to 1. So now print D. So wherever there is uppercase B, the compiler will replace it with 1. So here you'll have printf %d B. So obviously 1 is going to get printed. So the right answer is this option B, which is 1. And I hope this was pretty straightforward and clear to you. And please feel free to ask any questions if you have any. Otherwise, we are done going at the last MCQ, which we are going to discuss and then move on to the coding assignment. So what will be the output of this code? So you see hash define A equals A10. So this value of A is defined as 10. So as soon as you define anything, you cannot use it as a variable. So here what you see is that later on int A equals 50 is been used. So this is invalid because wherever sees the compiler sees A, it replaces by 10. So so this kind of negates the fact that you can create a variable with the same name as what you have used for defining the quantity. This is like a constant, and you cannot create any variable or change this value anytime in the code. So the problem here is that you this line where you are creating a variable of name A of type int, and this is not allowed, and this will give you a compilation error, and hence the right answer here is option D, compilation error, is exactly that you will get. So we are at the end of all the MCQs where we have covered different kinds of algorithms for swapping and also sorting arrays and finding elements in an array, find the index of element in an array, and which we are looking for, and also we have covered some stuff related to preprocessor macros in C. And I hope this is a fair and comprehensive list of all these to get you started. And now we can move on to the different coding assignments. And at this point, if you have any questions, please feel free to ask. Okay. I don't see anything on chat, so let me move on. So write a program to print all the locations at which a particular element is taken, a particular element taken as input is found in a list, and also print the total number of times it is in the list. The location starts from 1. For example, if there are 4 elements in the list in the array, and if we search for element 5, we will print 5 is present in location 1, 5 is present in location 3, and 5 is present 2 times in the array. Okay, so let's try to code this up. So for that, I'll be using VS Code as always. So let's do this. Let me rearrange this for you so that it's easy to see. And so I already have one Hello World program, which we will be getting rid of in here. And let's have something like this, and then we can use this like a preprocessor thing. So I'll define something like, let's not have it. Let me see what are the test cases based on which I'll assign the size of the array. So always this is 9, 1, 2, 3, 4, 5, 6. So let me then assign the size to however I want. Oops. Sorry about that. Okay. So then size, and let me then print enter size of the array, and let me take in the size, and let's then create an array of size, and I'm assuming that the largest thing is of 100 because no array is larger than that. And I'm not going into the details of dynamic array allocation just for the sake of this simple code, but yeah, that is something which you can also look up later on. Okay, so now let me open a for loop. Okay, so this is how I just put the elements in the array, right? So let me also print the array as well. So let's just do array A equals so just print the array in here. This, and here I'm going to print the array in here. what I'm going to do, and then I will just do I. This is going to print the elements of I. And once I've done that, now the next part will start, where I'm going to find out the element which I'm looking for. So let's take that as an input from the user. So this is it, and enter the element to search, and I'll take the search element, and I will also do a count equals to 0. So this is going to count how many times the thing has reached, and so I will do something like this, and as soon whenever I find this, I will do something like I plus 1. So whenever I find it, I'll see that the element found at this index, so this will be the position where I'll see, and I'll do count, right? And I'll do, if not found, count equals to 0. I'll do this, else I'll do that the element was found this many times. So this is what is done. So let's save this and try to run this code. But okay, I think this is something which is not needed. Let me save this. Try to run the code. Okay, so enter the size of the array. So now let's try the test case. Where I'm going to enter the size of the array. So the first test case is here, which is 4, 5, 5, 6, 5, 7. So 1, 2, 3, 4. So it's an array of size 4. So let's me 5, 6, 7. So array is 5, 6, 5, 7. So that's what I see, 5, 6, 5, 7. So enter the element to search. So let's, so element found at index 1 and index 3, and 5 is 5 element found 2 times. So we found the 5 2 times. So this seems to work. So let's try the other test case as well. So enter the size. So let me make this a bit larger so that it's easier for you to follow. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 elements now. So we have 7, 30, 50, 90, 30, 20. So this is the array that we are having, and now let's look for the value of 30, because which is what we want to search. So okay, so let's see, 30 is present at location 1. So but you see that location starts from 1. So this is not right, because you see that the 30 is present in actually not location 1 but location 2, because you say the code says that the location starts from 1. So they but here the location is started from 0. So you see it's offset by 1, but I think given whatever has been asked, we are doing this right. So you see that 30 is present at location 2. So 1, 2, 3, 4, 5. So then it's present at location 5, and then 6 and 7, 8, 9, all these 3 locations also. So total it is present, you see 1, 2, 3, 4, 5, 5 times, because 1, 2, 3, 4, 5. So you see it's present by a total of 5 times. So this I think is not the right, because for this specific test case, right? For example, you see this 80 is present and 80 is not present in the array is not right. So there is something which is not right with these test cases, and the code which has been written in here seems to work fine. Okay, so now let's move on to the next question. So let's see what that is. So this is write a C program to search a given 1D element in the array and display the position at which it is found using the linear search algorithm. Okay, so I think we can use a large part of this code, so we'll retain that. And here enter an element, so we are enter the element, printf, enter element I+1. So we are entering the element, and here we are searching for that, right? So till this is okay. Search a given element in a 1D array and display the position at which it is found by using linear search. Okay, so we'll just display the position. This is actually simpler than the previous question where we just do this and we see that element is found here, and we see that if count equals to 0, we'll say that element is not found. And we do not need then the else statement. So that's all. There it is to it. So let's try the test case where you see that I don't again find the reason for, because you see that the case where the array has been given as this test case, and it says that 95 is not present, but you see 95 is obviously present in this array. 95 is not present in the array is not right, because you see that the array and there is 95 in the element, right? So, and you see here 6 is present at location 1. So let's try test case 1 and 2, and instead of looking at what the output is, we will see whether the output that we get makes sense or not, because these are not right. Okay, so enter the size of the array. So 1, 2, 3, 4, 5, 6. So this is an array of length 6, and let's now put in the elements 45, 65, 85, 25, and 95. So now this is, just to confirm, 4, 45, 65, 85, 25, and 95. Okay, so now let's find out the element to search. So we will search 95, which is present at index 6, because you see that the last index is 6. So we can do this once again. And now we will give something, is the same test case, but give something which is not present. So for example, let's just put the array once again. 25 and 95, and we'll get 38, which obviously you see is not present in here. So you see element not found. So obviously this seems to work fine. And let's try the other one as well. So this just gives you the first occurrence. It doesn't give you the unlike the previous program, it doesn't give you all the occurrence, but just gives you the first occurrence. And for that, what you need to do is you need to put in a break statement. So this just gives you the first occurrence. So for that, you need the break statement in here. So let's do this. And see the second case where 1, 2, 3, 4, 5, 6, 7. So there are 7 elements in this array. So we'll give a 7, and then just keep on adding the elements. 9, 5, 4, 7, and 6. So this is the array 5, 6, 9, 5, 4, 7, 6. 5, 6, 9, 5, 4, 7, 6. And now we will give search for 6. And 6 is obviously found at index 2, because as you remember that this is for us, in C, the index starts from 0, but as the code says that we will start counting from 1. So you see that 1 and 2. So this is the second position where this occurs. So that's why you get index 2. So this is this makes sense. Okay. If there are any questions at this point of time, then please put it on chat, or you can unmute and ask. Okay. Since there are no questions, I'll move on to the next one. So next is about write a C program to search a given number from a sorted 1D array and display the position in which it is found using binary search algorithm, and the index starts from 1. So again, we will do a binary search in here. This was all using linear search. So we will just change our searching algorithm, but the rest of the part is going to remain the same, right? So, okay. So let's do that in here. So let's have a for loop while this part is going to change because now we are going to implement a binary search, as you see. So for that, we will first look at the midpoint of this array, right? So before that, then requires int low equals to 0, right? And high equals to size minus 1, because size is the size of the array that we are taking in, right? Now we are going to do, and obviously we have something like int mid, which we will be creating every time you see here. So mid equals 2, so you will have low plus high minus low by 2. So this again, recall this is from this formula that low plus high minus low by 2. Or you can also do simplify this to have something like high plus low by 2. So whatever you wish. So let's go back. This is binary search, okay? And now we will be checking the position of mid, right? So we'll do like if mid a equals to search, then count plus plus, and we'll break it. Otherwise, we will do something like low, which is, so here you see that if this is equals to search, then we have found the array, we will increase count by 1 and we will just break the for loop. Otherwise, what we will do is that we will check the value of a mid with search, and if we see that a mid is less than search, then we will know that the search is to the right of it. So the low is then have to be mid plus 1, and else the low should be mid minus 1, right? And then what we need to do is we have to keep on changing our value of I to the different value that we would need here, right? So the array is now going to change, and the way that is going to change is we will do something like this, and this has to be compared with high and has to be compared with low, right? So you start with high, you go to less than equals to low, and you do I plus plus. So this is kind of the thing, and your for loop ends in here. Okay, so every time you do this, your low and high is going to change. So the portion of the array that you have to loop over and search decreases every time you do this. Okay, so I think this goes right, and once you come out of it, you check if count equals to. So now you do something like you see that your count is greater than 1, equals to 1, then you see that obviously the element is found, and the place where you have found this element is mid plus 1, because as you see that our index counting will is plus 1 as asked by the code. Otherwise, you say that the element is not being found, right? So I think this is working version. If this doesn't work, then we will try to debug this, but let's first try to run this code and see whether we are able to get the test case or not, right? So let's see. So for this 2 3, so this should give me 3, because you see that it is at the third position that you find 2. So let's see 1 2 3 4 5 6 7 8. So this is 8, So we have 8 elements. Got it. I think I understand how this is written. So the way this is written is the first 6 in this case is the length that it takes in, and then it takes 1, 2, 3, 4, 5, 6. So these are the 6 elements that it takes in, and then it's asked for the element to search for. Okay, so now I get it why these test cases are not matching. So what this inputs mean is that you first take the size of the array, and then you take the elements of the array, and then you take the element to search. Okay, so this is not the entire array, but these are the inputs that you are giving to the program. Okay, so let's then give 6, and then give 1, 2, 3, 4, 5, and 6. So let's see the element to search for. It says that the element is not found. So let's see what is going wrong with this code by using the debugger. So for that, I'll just make this large because now we are debugging and going through the code. So let's start with this. And let's try to debug this. Okay, so we'll put in 6, and let's see, 1, 2, 3, 4, 5, 6. So enter the element to search. We will be searching for 2. Okay, so let's do this. So we'll step over, and you see I is 0. So I starts from 0, and you see mid value. So we'll look at the mid value, and here let's see the mid value is 2. So 0, 1, 2. So let's see for this specific array 0, 1, 2. So a mid is 2, and we see that this is equals to search or not. So this is obviously not equals to search. So we come here and we check if the value of a mid 2 is less than search or not. So the search is, this is a mid 2 is 3, so this is not satisfied. So we okay. So we see that a mid 2, which is the value of mid, is 2. So a 2 is going to give you 3. So 3 is equals to search, which is obviously not satisfied. Now 3 is less than 2, which is obviously not satisfied. So we come in here and we set high to mid minus 1. So we set high to mid minus 1. So you see the high is going to then this else is then satisfied, and then high is previously, let's see what was the value of high, which was the size of the array, I would believe 5. So now it's going to mid minus 1. So mid was 2. So high is now going to be mid is 2. So high is now going to be 1, right? And let's see, 1. Yes. So that's the part which we want to compare. Okay. So this seems fine. So high becomes 1. I come back, and now I equals to low. So now low is 0, and this is satisfied. Just come in here, and then again I search for the mid one. So between so this is 0 and 1. So mid is 0. I search for this. Okay, so let's see. So this is where the problem is happening, because you see that the mid has been set to 0, and as mid gets set to 0, it's searched with search, which is 2. So A0 is obviously, so we had to search with A1 first, right? So here, let's see, try to debug this, because what we want to do right now is we have sliced the array, and here we have 0 and 1, right? And now we see that A0 is not, so this is the mid value which we take in, and we check that if this is equals to search or not, right? And we see that it is not, so we come in and set here, and then A mid is now A0. So now we are at A0, so A0 is less than search. So A0 is 1, so 1 is less than search. That's right. So we put a mid plus low is mid plus 1, right? So let's see. The low is now set to 1, while we come back, and then we do something like I equals to low. So you see low is 1 and I equals to 1. So we come in here and we go out of this loop, right? And this is where I think the problem is happening. So we have to do this less than I, so that we come in here and we are then able to kind of have the right thing. So let's stop this. I think the problem was less than equals, because we want to go in this loop and then we are going to see the check whether this is happening or not. So let's save this and run this code. Have 6 elements, 1, 2, 3, 4, 5, 6. It still says element not found, so let's try to again debug this. One, two, three, 4, 5, 6, and 2. Okay, so here we are coming in the first value. So we set the lows and highs. So high is set to 1. We come back and then we check once again. Okay, so I think So let's think what's going on in here, because at the end, the low and high is now corresponding to the same thing, and that is when the code is breaking, because it has to go in there and then only we will be able to search it, because you see that that was set to 1, so mid has to be then 1, and then only it will is going to match. I this. So let me have 6, then 1, 2, 4, 5, and 6. Who is the element to search for? Let's go in. It is not equal. Takes the high one, comes back. The mid is now set to 0, and obviously doesn't match. So the low is now getting adjusted. Comes back, and now so the low and high both are now equals to 1, and that is where this needs to check. So this is not it, but I think this will be a while loop for sure. So we can also do this low is less than or equals to high. Then only we'll do this. Otherwise, we will not. So now let's stop it. Let's run this code. 6. Yes. So 1, 2. Okay. So now this works. So the thing to do this is while low is not less than or equals to high, because as a low is going to cross high, then only then the problem will then we are at the end of it and we have not found the array. Otherwise, we have found it. Okay, and so this is now working. So just to understand this, I'll open the debugger once again to just briefly walk you through what's happening, and that will give you a clear idea. Okay, so let's enter the size of the array. So it's 6, and then 1, 2, 3, 4, 5, and 6, and we'll search for the element 2. So you see now low is set to 0 and high is set to size minus 1. So obviously low is less than high, so we go in. Here mid is set to, then mid gets changed to the midpoint. So this is 2, as you can see, and we just go in here. This doesn't match because this doesn't match, and now we know that the a mid, which is has the value of 3, because as you can see a mid is 2, and then a mid has the a of 2 is 3, so a mid has the value of 3, and because a mid has the value of 3, 3 is less than 2, so this is satisfied. So the low is set to mid plus 1, so we know that uh, so so this is, sorry, this is not satisfied. So you see a high is set to mid minus 1, because we know that we can discard the rightmost part, so we just go reduce the place where we want to search it. And when we come in here, and then again we come in here, and we see that still our low is less than or equals to high, because low was 0 and high was 1. So we come in, and here we again set the mid to the new value. Mid is set to 0, and now a0 is obviously not equals to search. And here we then do a search else if. So a mid 0 is less than search. So now if this is a mid is less than search, we come in, and here we see that a low equals to mid plus 1, because now a0, which is uh, 1, is less than the value of 2. So the low is now needs to be adjusted from left to right. And so that's why it goes to mid plus 1, and else part is obviously not evaluated, and we come in for the last time. Here you see that low is now equals to high. So this is where we come in, and the mid value is then therefore the same as low and high. So mid is then again gets assigned 1, and now you see that of course we now go to the place where now a1 matches 2. So we come in, we increase the count, and we just come out of the loop statement. Okay, and that's it. So here we are at the end of it, and our count is greater than equals to 1, because we have increased the count, and we just print it, and this is the end of the thing. So just to test it, we can just now run other test case as well. So let's run that. So the other one is take 7 elements. So 40, 50, 60, 70, 80, 90, and 100, and just looks for 100. Or let's take this. So 5 elements, it starts from 10, goes to 50, and searches for 40. So let's do this. 20, 30, 40, 50, and we search for 40. And the element is found at position 4. So as you can see, the element is found at position 4. So initially there was this confusion that what this test case means. So we got to figure out that this test case means that first means what's the size of the array that you are going to enter, and then the next are the elements of the array, and then next is what you are going to search for, and then this is it. And let's take the last case where we do not find anything. So let's run this once again. So enter the size of the array. So let's see. This is of the size 4 and 44, 55, 66, 77. Okay. 27, and we had to search for 10, so it's element not found. So this is working perfectly. Okay, so we are done with this. So let's move on to the next program, where write a C program to reverse an array by swapping the elements and without using a new array. So we are going to swap the elements, but we are not use a new array for swapping that, right? So for this, this is a relatively simpler one compared to the other searching and sorting algorithms. So let's also go and check what program 5 is. To merge two given sorted arrays sorted in ascending order, and the code input is already written. You have to write the merge function so that the merged array is displayed in ascending order. Okay. So this is actually pretty simple. So you have to sorted arrays, and you just have to write a C program to merge two given sorted arrays sorted in ascending order. The code for the input and output is already written. You have to write the merge function so that the merge of the array is displayed in the ascending order. So actually the idea is simple. In here you have two arrays and you have to just search for this. But let's do that, and then we will move back to question number 4. So let's see how the test case was designed. So this takes in the array and then gives the sorted array. So this is the first 5 elements, and then the next array has 3 elements. Okay. So let's take this. Okay. So similarly, I'll do the same thing. I'll call this size 1, size 1. I'll go till size 1. And I think this is okay. So I'll go till size 1. And then I'll do a print f of /n. So I just print a new line, and then what I'm going to do is the same thing to get the next array, right? So this will be size 2, and this will be array 2. This is going to be array 1. And let's define, call this B. So I'll take in the elements of B. So this takes in the elements of B and just prints the element of B, right? Printf s/n. Okay, so now the next part is merging the two arrays to create a new third array, which is in ascending order as well, assuming that these two arrays are in ascending order. So I'll int C100. So this is this. And now what I'm going to do is here I'll going to check the last element of the first array with the first element of the second array. So a size 1 minus 1 is greater than b0. So that this would mean that the first array is kind of arranged in ascending order, and the last element in this array is obviously, you see, it's greater than, so say you have 1, 2, 3, 4. So the last element of this array has to be, if it is, let's see what condition I give, greater than the 1. So then that would mean is that the second array has to come before. And if the last element is smaller than the first element, then the first array has to come before. So now let's go through for loop for I is equals to size 1 plus size 2. So this is kind of the total size. And then And what will happen is, okay, so CI, so CI will be then AI, and after this, size plus I, so this will again go till size 2, and well, CI will be BI, right? Else, what will happen is we'll do the reverse thing. Else, first we will first the elements of B will come, and then the elements of A are going to all come, right? And at the end, we are going to print elements of, and I think this is what is needed in here. So let's try to run this. Okay, so enter the size of the array 1. So let's now test it with what we had. So first is 5. So we will have 20, 30, 60, 70, and 80. And now the second one, this is 30. So we'll have 10, 50, and 100. Okay, so I think something is not right in here, because let's see. So what did we do? In here, we have taken in the array and we have printed it. So the next one, we will go till, oh, size 2. Okay. B array has to go to the size 2, and this is it. And so we are going to stop the code. Yeah. And then we are now going to do the sorting algorithm in here, right? So that's kind of the problem you see, which we have encountered. So I am going to also have a print statement later. So let's first take the inputs and then we will print it. Okay, so we'll take the input in here. And then we are going to take in the values of C. So once we have taken in the values of C, it's now we are going to, as you see that the C array at the end is like a sorted thing. So now we will do kind of a sorting on the array, right? So let's take the code for binary sort. We have created the C array, and let's do the sorting algorithm. So for now, we go on in here and we have an a j. So let's not do this, but call this as int j before doing this. And with size 1 to size 2, and if ci is greater than cj, then we do this temp and we move on and we do this, and then we print the array, which is then sorted. So I think this is the question. It was that you have to write a merge function so that the merged array is displayed in ascending order. So we merge the array and then put this in ascending order. Okay, so now let's try to test this. So let's do this array 1. 5. So we have 10, 20, 30, 50. 60, 70, 80. Okay. I think I have not given the right values. So let me run this once again. Let's see. The first is 5 elements. And then you start with 20, 30, 60, 70, 80. And the next is 3 elements. So you have 10, 50, and 100. Okay. So B, 10, 20, 30, 50, 60, 70, 80, 100. Let's see C, 10, 20, 30, 50, 60, 70, 80, 100. This is working fine, but B is not properly printed. So let's see. I think I have missed something to do with size 1 and size 2 while printing it. So let's see that. Yes, it should be size 2 because B runs still size 2. Excuse me for that. And let's run this code once again. Okay, so let's try the other one because we have already tried the one. We've seen the sorting is working fine. So 10, 20, and 30, and 4. We have 40, 50, 60, and 70. So we have this, and then C is 10, 20, 30, 40, 50, 60, 70. Okay, so this seems to be working very well. So let's try the first one once again because we encountered a small error which was not related to the output but the display of the input variables. So just to clarify, 20, 30, 60, 70, 80, and then there are 3 elements in here which is 10, 50, and 100. And obviously you can see 10, 30, 40, 50, 70, 90, 100. So 80 and 100. So all these get sorted and the C array is getting printed in ascending order as expected. Okay, so let's move on to the last assignment of this week, which is having to reverse an array by swapping the elements without using a new array. So it's like you see 7 elements and it starts from 8, 9, 10, 11, 8, 9, 10, 6, 4, 7, 11, and you start with this and you start with 11. You just do it from the other side and you just print the array with reversing it. Okay, so let's do that, and that will be the end of today. So I will get rid of all of these because I'll just take in just one array right now. And now I'm going to right. So this just prints so this is just size, which I'm going to go through. I just now have one array which I'm going to print, and all these are not required. All I'm going to do is A equals this, and we have a printf of /n. So A gets printed, and then the reverse of is what I want. So for I, which is going to go from 0 to size by 2, I++, and end is size -1. So now what I'm going to do is do something like okay, so now let's go back and see what was the question. Swapping the elements without using a new array. So we are not using a new array, so this is fine. So we make this, and this is int and we have one temp just to have this int temp temp. So this is the temp array, not temp array, but temp variable, which is the like a temporary variable, which is in here. Actually, we can also define it in here as well. So here AI and then end, and AI will get swapped. And then at the end, we are going to print the same variable A, which will go till size, and you'll see that this is going to get reversed. So let's see if this code works fine or not. So enter the size of the array 1. So let's again move this window to one side. So it's 7 elements. So it's 11, 7, 4, 6, 10, 9, 8. So, okay. And so, okay. Oh, I gave the other way around. So I gave this one and then, okay. Let's run this once again. Okay, so this is 7. So it's 8, 9, 10, 6, 4, 7, 11. So you see 8, 9, 10, 6, 4, 7, 11. And the other one is 11, 7, 4, 6, 10, 9, 8. Okay, so this is reversed and working fine. So let's run this once again. For the other test case, say let's try test case 5, where I have something like 50, 60, 40, 30, and 20. So 50, 60, 40, 30, 20, 50, 60, 40, 30, 20, and we have 20, 30, 40, 60, 50. So we have 20, 30, 40, 60, 50. Okay, so this works fine. So I think we have made the test cases and checked that this is indeed reversing the array A, and we are not using the the second array to reverse this array. So we have started with array A and kept only that array and just reversed all the elements of that array without using another array. So this and we have checked the test cases. It seems to be working fine. And this is the end of all the coding assignments. I hope that this has been helpful to you in understanding arrays and different sorting and searching algorithms, and also using preprocessor macros in many cases. And on that note, I would like to end the session today. And if you have any questions later on, feel free to post it either by emailing me or in the next session when we'll be starting week 10. So on that note, I'm going to end this session. Goodbye to all of you. Thank you for listening to my talk, and thank you for participating in this session. Thank you for your time, and goodbye, and have a nice weekend.